Everybody, I wanted to go over how to draw intermolecular forces on a sheet of paper because they are sometimes kind of a little bit difficult to do, and I'm going to show you one of the examples that we have been doing already. So we are going to take a look at our trusty friend methanol here, CH3OH. So what I'm going to do is I'm going to draw the Lewis structure for CH3OH. And what I want to do is I want to figure out, kind of like I always have been, the partial negative and partial positive charges on these molecules. So what I know from our past experience is that the O is partially negative and the C is partially positive and the H is partially positive in our Lewis structure here. So what we're going to do then is to draw the intermolecular forces, or the attractions between the two molecules. I need to draw a couple different molecules in here to show how the different things interact. So the big thing we know with intermolecular forces is that the positives and negatives on opposite molecules need to be oriented towards each other. So what I'm going to do then is I am going to have the H and the OH from another CH3OH, and you'll notice the one that I'm drawing here is kind of a mirror image almost. If you like took this guy and flipped it over, you would have this Lewis structure. So I've got a partial negative and a partial positive here. So what I'm going to do to draw the attraction is I'm just going to draw some dotted lines to show that these are attracted to each other. Okay, so then if I wanted to get another molecule in there, because the College Board likes you to draw usually at least 3 molecules to show that you know what you're doing, I'm going to draw another one below, and I kind of just drew this janky, so you'll have to pardon me. Let's see, we'll try that again. Okay, so what I have is the particles are attracted to each other via the oppositely charged part of the molecule. So the partial positive of one side is attracted to the partial negative of the other. Now, in the case of these bonds here, these interactions could be represented as dipole to dipole interactions, but more importantly, they are hydrogen bonds. So these lines that we're drawing here for attractions are technically hydrogen bonds in this situation. Remember, hydrogen bonds are just a stronger dipole to dipole. I have never seen the College Board ask you to draw a London dispersion force because there's no permanent dipole that's happening. So that is something we tend to not worry about quite as much, but that is what they are doing. So things that you're going to want to include in your intermolecular force drawings. You're going to, want to figure out your correct Lewis structure. Okay, so we need the Lewis structure. Then we're going to need our dipole charges. You are going to need at least 3 molecules together. Okay, and then the last thing you're probably going to need are going to be some lines of attraction. Okay, a caution for you. Something you cannot do. I'm going to kind of redraw another one in here. Let's go like this. Okay, so here's another one that I want to show an attraction to. If I go like this and I draw a straight line, that is incorrect. No, 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 don't do that. That is a bond. So if I want to draw an intermolecular force, I have to draw the dashed line to show that there is an attraction there. There is not a bond. So if you draw lines in there, so if you would make all of these dashed lines here, straight lines, that is not correct. In an ionic bond, that is correct because it forms that lattice. But in a sorry, losing track of my thought. In an intermolecular force, it's just a dashed line, not a straight line itself. Okay, so hopefully that clears things up. If you have any questions, let me know as we get into our meets.